we're going to take a look at something today that you probably have very rarely seen, if ever. It's called the matrix. Okay, and I'm not talking, about an old Keanu Reeves movie. No. Matrix is just simply a way of putting information in and doing bulk operations on it. It's just a faster way of doing it, putting the data in and doing a whole bunch of stuff to it. Now, the matrices can look like anything that they want. They're always going to have a number of rows and a number of columns. So if I look at A here, this is a 3 by 2. 3 rows, 2 columns. Always identifies rows by columns. So B is a 4 by 1 matrix. That's all it is. The stuff that's inside, we identify them as elements. That's really all that it is. Now, matrix addition, it is simple. First one gets multiplied with the first one, second with the second, third with the third, fourth with the fourth. I mean, it would do exactly what you would expect it to do. If I've got a 4 by 4 matrix here and a 4 by 4 matrix here, first one gets multiplied with the first one, second with the second, third with the third, fourth with the fourth. It's what you would expect it to do. So, if I want to create the matrix, all it is just pulling the numbers right out of the table. So if I got a table here of information, 82, 54, 8, and 0, you'll notice that this matrix down here, 82, 54, 8, and 0. Whatever is in line 2, line 2. Row 3, row 3. Okay. Did the same thing over here. Now, as long as this table has the same information as the other table, the matrix will have the same kind of information as the other matrix. They can be added together. I've got a 3 by 4, a 3 by 4. I get to add it up, and I get this table down here. What does that table mean? What does that matrix mean? What was the first one? Male students. Next one, female students. I add them all up, that's the total number of students, right? That's all it is. It's just a quicker and easier way of identifying the information and working with it. So, now, there is something called a zero matrix. You can get zeros. A lot of people always think of zero as being nothing. Well, zero has a value. It has the value of nothing, but there's nothing there to use. Nothing that you can use to calculate. It's just going to be zero. So, getting to that, subtraction works exactly the way addition did. First one gets minus the second one. There you go. Keeps on going through. It does what you would expect it to do. So, first one I want to go and take a look at here is this idea of additive inverse. So, if I want to do the matrix for this one, now a matrix is always going to be having brackets like that around it. If it doesn't have the brackets, it's not a matrix. Additive inverse tells us to do what? Well, what? Well, we're going to add. But what's add and then the inverse? What would be the inverse when we want to add? The opposite. So, if the first one is 10, what's the additive inverse of 10? Negative 10. What is the additive inverse of 0? 0. The additive inverse of negative 3? 3. Negative 6.5? 3. And negative 4. That's it. So whenever we're looking for the additive inverse, it's just simply the opposite. That's how we've always taken a look at it before. Whatever number we get, additive inverse, opposite number. Okay. So let's try this. I want to find what that's going to be equal to. Well, again, going to have a matrix. So, if you had to guess, what number do you think you'd get? Well, I got a 4 and I got a -1, so they're being put together. And they're subtracting, right? Or I should say a 3. So if I got 3 minus -1, what would that be? Oh, but I got 2 negatives in a row. So that would be 3 minus -1. Here's where going and writing out your work is going to be a lot easier on you. So this goes plus plus, and I end up with 4. Down here, -23 minus -18, plus plus, so I end up with -5. Here I've got 16 minus 9. Well, that's just going to be what? Nothing tricky with it. It's just going to be 7. Here I've got 0 minus 14, so it's going to be -14. All that it's doing. Right. All you have to remember is when you're adding or subtracting matrices, the same one that's in the same spot, corresponding places, either add or subtract them. That's all you're going to do. Nothing too tricky. Nothing too tricky at all. Now, this one. I want to find out what x is. Just like any other time, you're going to have to go and do a little thinking about it. If you need to, write it out. Now, for this one, oops, x is going to be equal to. So if I look at this, it's got to be some number in here. So 3 plus something is equal to 5. What's the something? 2. So that's got to be 2. Okay. Let's see. 9 plus something has to be equal to 2. That's got to be what? -7. Because you've got to subtract the 7. Here I've got 7 plus something has to be equal to 9. That's 2. And then here I've got 1 plus something equals -6. So that would end up being what? -5? Okay. When in doubt, work it out the algebra way. Subtract 1 to both sides, subtract 1. X is going to be equal to -7. So this turns out to be -7. So, I mean, a lot of times you'll be able to take a look at it and say, hey, oh, I know exactly what's got to go there. If you have a problem with it, then you need to go and write it out algebraically and do the math. It's not that bad. Well, let's see what else I got here. Now, next one here, scalar multiplication. If you have a number out in front of it, everything gets multiplied by. Just like you'd have a set of parentheses, if I've got a number out in front of it, in a set of parentheses, everything gets multiplied by it, right? Same idea here. If I got a number out in front of the matrix, everything gets multiplied by it. So, let's take a look at this for a moment. It says the table show proposed fee for a new toll road. No one is happy with either plan. Some believe the fees in A should be doubled. Other believes the plan B is appropriate if the fees are reduced by 25%. Create matrices A and B and find out what the difference is going to be. So if I'm supposed to go and double everything that's in here, does that mean I take 2 times this, 2 times this, 2 times this, 2 times that, 2 times that, 2 times that? That would double everything in there, wouldn't it? That's exactly what you got to do. If I go over here and they say it's supposed to be reduced by 25%, if I take 25% away, what percent do I really have left? 75%. So if I take 75% of this and this and this and this and this and this, do I get my new prices? Kind of like going shopping and finding out that everything in the store is 25% off. So you're really only paying 75%. So what I want you to do here is I'm going to give you a few minutes. I want you to start with this one. So give you about 90 seconds, and I want you to do this problem. Close a little. Looks like easier. Gives you more room to write. All right. So we're supposed to find W plus E, right? So if I grab these values and put them in a matrix. Now again, I've seen some of you are using parentheses and squiggly lines. Make sure that they're the square. Because I can guarantee you ACT test, even on the MCA test for graduation, they have these things there and they do identify with parentheses, brackets, braces. I should know, I helped create the tests. So that means this one is 13, 1, 4, 6, 8, and 2. This one down here is simply going to be 0, 4, 11, 2, 3, and 5. So if I want to find west plus east, here, I would take 13 plus 0, which would be 13. 1 plus 4, which would be 5. 4 plus 11, which is 15. 6 and 2, which is 8. 8 and 3, 11. 2 and 5, 7. Now, do I realize that you can sit there and look at this and say, oh, that's easy, just add them all up from there. That's all it is. It's just that things will get stored in the matrix and go from there. Because there are other things that we can do with these things. So does anybody disagree with my numbers? Good. Oh. So let's give this one a try. And I'll give you about 30 seconds on that one. So, Mr. Anderson, what is the inverse matrix for this one going to be? And then we got to make sure that we have the brackets around it. There we go, that's it. Okay, let's try. All right, I'll give you 90 seconds on this one. All right, so Bailey's gone, bummer. Jordy, which one goes right here? -3. Good. And let's try. Let's see, it gives us Damien. What comes down here underneath it? Okay. Oh, Cole's already had a question. Let's see, that goes to Micah. What's down here on the bottom? And we've got David. What goes up here? Well, not really. Because you got 0 minus -4. So then it's going to be plus plus. Always write things out. Always write things out. Especially when you're doing subtraction, because those negatives are going to kill you. Let's see. What do we got? 13. Kitty, what comes next? -7. Good. And let's see. Noah, what do we got down here? Absolutely correct. because you've got 3 minus a negative 3 plus plus 6. You seen that you had 0 and you're going, oh. Yeah, you got to be kind of careful with that stuff sometimes. So, always watch the signs. They will definitely get you. So, let's try this one. Alrighty. Give you 90 seconds on this one. Yeah. So, doesn't like giving me other people, does it? Riley, what you got for the first number up here? Huh? 8? Good. Because 8 minus 2 is that. Absolutely correct. That's 3. Noah's already had one. Let's see. We'll go with, I'll just do it this way. Eli, you haven't had one yet. What should be down here? Negative 14. Okay. Yep, because we got minus minus. So that goes to a plus. That's good. Let's see. Kai, what do you got up here for this one? Which one? 20? 1. 1. I can't hear. Half. I know I'm getting. All right, so, okay, Mr. Garth, so what goes down here? Negative 6? 10. I like 10 better than negative 6. Because 10 minus 8 gives me the 2. Good. So, let's try this. I'll give you 2 minutes on this one to kind of think about it. A little on the trickier side. Yep. You got to find one for X. Got to find what Z is going to, or Y is going to be, and you got to find what Z is. It's not as bad as it looks. Absolutely not. So easy I can. I like that one. So easy you can do it. of the time the problem with mathematics that people have with it is they look at it and they go, I can't do it. Take a look-see at it. What do you see? A mess, yeah. Okay. Life is a mess. This is easy. Okay. Whenever you get something that is completely and totally foreign to you, you try and figure out what what can I figure out? What do I see? What do I know? Well, it says that this matrix is equal to that matrix, correct? So I see a 10 here, and I see a 10 here. I see a 1 here, and I see a 1 here. So what could I possibly conclude from that piece of information? They have to be exactly equal, right? So if 10 is there, 10 is there, 1 is there, 1 is there, x is there, 25 is there. What does x have to be equal to? 25. Because that's 10, that's 10, that's 1, that's 1. I don't know what belongs there, and there was a 25 here, so that means that there has to be a 25 there. You lost? Okay. Okay. Let me try this one for size. Let's see. What do I want to do now? This. Okay. So now, this is the instance for it, right? This matrix and that matrix. They're supposed to be exactly the same. Now, if I go and take this and lay this right down on top of here, okay? I've got 3 across, 2 down, 2 down. And if these are supposed to be exactly the same, because if I look here, I got a 10 and a 10, right? Here I got a 1 and a 1. So if this is the case, where I've got 10, 10, 1 and 1, x should be the same as what? 25. So that's why x is 25, because these two go together. Because those two went together. Because those two went together. So what that tells me then is that x plus z has got to be 20. What is z going to be? So if I go and take a look at this again, move this down here a little bit. And now I'm looking at this and I want to see what's going on here. Well, I got that going to here. That doesn't help me. That going to here doesn't help me. This goes to here, so do I have a number? Okay, so I know now that these two go together. So that means that z is equal to -5. So that helps, right? So now I've got to figure out what in the world x plus z is. Well, what is x plus z? Well, what number should it be? It should be 20, right? Because x plus z is 20. What's x? 25. What's z? -5. What's 25 plus negative 5? 20. So it matches up. Now it says here we get x minus y. Okay? If I take x minus y, what's that supposed to be? Yeah, because x is 25, y is 20. They got a bad number there, don't they? Because that doesn't match up if I know what x is and I know what y is, does it? So that shouldn't be 18. That should be what? That should be something like along the lines of 2. Let's go back here to the book once and see. No, I don't have. Okay. There we go. Cool. Cool. Let's see. This is that. What's that? I always love correcting textbooks. Yeah. It says y is 7. Let's take a look at that again. Y is supposed to be 7. Interesting. Oh yeah, 25 minus 7 would give me 19. Oh, gee. My brain is offline, isn't it? Boy, am I running out of steam today. Duh. Why did I put 20 there? Probably because that's what x plus z was, is 20, so I put 20 there. So now, y is the only one that shows up over here, so x minus that, 7, makes a heck of a lot more sense, doesn't it? There are days. But does 25 minus 7 equal 18? That makes a ton more sense. Always helps to actually pay attention to what you do. Right? So, let's see. 9 minutes. Oh, good. Then we can take a look at this one. All right. I'm going to give you a couple of minutes here, and I want you read through this and find out what the prices are supposed to be. Yes, sir. What? Okay. You read through it, right? Okay. So, Theater A is going to sell their tickets at a discount of 20%. So, it's going to be some money off, right? So, think of it this, if the sale price is 20% off, what are you actually paying? What percent are you actually paying? Put it to you that way. 80%. So what you can think about then is, since it's supposed to be 80% of the price on it, can I take and multiply everything in here times 0.8? That makes sense. Because of means to multiply, so 80% of this, 80% of this, 80% of that. Does that make more sense to you? because they're not charging full price, are they? Prices are going down. Now, Theater B, they're doing the same thing, but theirs is going to be 30% off the original price. So if it's 30% off the original price, what percent are they actually paying? 70. So that would be 0.7. So now, when it comes to the calculator, all you got to do is take the calculator. What's 80% of free, by the way? What's 80% of free is still free. Okay, so this is going to be $0 over there. What's 80% of 450? 360. So this one's going to cost $3.60. How much is the adult one going to cost? How much? $6.80. And how much are the senior citizens going to cost? $4.40. Okay. So, Theater B, are the children still free from 0 to 3? Yep, they're still free. What is 70% of $5? $3.50? 70% of $9? $6.30. And 70% of $6? $4.20. Now, the other thing that they wanted you to do is they wanted us to find out what the cost or the comparison was between the two. Okay? Find the matrix that represents the difference of the sale prices. So, if I do A minus B, that means that I'm going to be looking at matrix that go. Do I even have to put the kids down? No, I wouldn't really need that. 360, 680, and 440. Minus matrix B, which is 350, and I got 630, and I got 420. So if I go through and subtract that, what do I get? Well, that first one's 10 cents, right? The next one is 50 cents. And the last one is 20 cents. So, even if I go and take a look at it, what's the better deal? Theater A or Theater B? Theater B, because A is 10 cents more expensive, 50 cents more expensive, and 20 cents more expensive. So it is kind of an easier way to write it out rather than to have numbers just floating around in different places. It just helps you go and identify where to put